How about now, Hatini?
Aha! I think I have an idea. Hello everyone. My name is Hatini. Have you any heard about mixing problems? Mixing problems are an application of separable differential equations. They are word problems where items or quantities of different values are mixed. Sometimes, different liquids are mixed, changing the concentration of the mixture. There are also word problems that require us to create a separable differential equation based on the concentration of a substance. Problem formula is dA over dt, which is rate of change of AP in the tank, equals to R1, which is flow rate liquid entering, times concentration of substance in liquid entering, minus R2, which is flow rate liquid exiting, times with concentration of substance in liquid exiting. Once we plug everything into the mixing problem formula, we'll need to treat it as separable differential equation, which means that we'll separate variables, integrate both the equation, and then try to find a general solution. Hi Liana.
Hi.
Would you like some hot drink?
Yeah, sure.
I guess the drink is tasteless.
Oh no, the cup is leaking. How about now, Hatini?
Aha! I think I have an idea. This real-life case is one of example in mixing problem. The objectives to analyze and solve mixing problems using separable variable and another method in ordinary differential equation to determine the amount of Milo after a certain time, to compare the experimental and exact value that was obtained, to apply for a solution obtained in MATLAB programming. Suppose that we have two chemical substances where one is dissolved in the other, such as instant Milo and water. The direction or instruction on a packet of instant Milo powder tells us to prepare the drink using package contents by adding hot water. An empty cup initially contains 100 ml of hot water in which there is 33 grams of Milo dissolved. However, the drink was tasteless. It made us want to make drinks that have perfect taste. Thus, we add another hot water that has 2 grams of Milo per ml into the cup at a rate of 10 ml per second, and the solution is mixed by stirring it thoroughly. However, at the same time, the solution leaked out of the glass at the same rate of hot water entered. How much Milo is in the cup after 20 seconds? How much Milo in the cup after 75 seconds? By using mixing problem formula, let AP be amount of Milo contained in the cup. Then dA over dt, which is rate of change of AT in the cup, equals to R1, concentration of Milo in water entering, which is 2, times with flow rate of water entering, which is 10, minus with R2, concentration of Milo in water exiting, which is 80 over 100 times with flow rate of water exiting, which is 10. Since the mixing problem equation can't be solved by separable methods, we may use integrating factor method. Thus, we find integrating factor. By inserting integrating factor into the equation, we get AT equals to 200 plus C times with exponent of negative C over 10, where C is a constant. To find C, we have to let A equals to 0, where initially the amount of Milo is 33 grams, and then we find C equals to negative 167. Thus, we get the general solution. So, the amount of Milo in the cup after 20 seconds is 177.3990 grams, and after 6 seconds is 199.5860 grams.
Let us see another way in order to solve the problem. MATLAB programming. Though MATLAB is primarily numeric package, it certainly solves straightforward DE symbolically. There are two methods which can be used to solve first-order DE. These include separation of variables and integrating factor. This is the coding that used in MATLAB programming in order to solve the differential equation dy over dt. While this is the coding that used to plot graph of the solution for dy over dt. The amount of Milo in cup reached steady state limit, that is well below 200 grams. Many differential equations that arise in natural and social sciences are separable. We can compare this method with various numerical methods introduced. We can also use this same type of reasoning to model variety of phenomena. 5 numerical methods are used in order to make comparison with integrating factor method. These include Euler, midpoint, Hun's, RK4, and modified Euler method. Solutions obtained finally tabulated in table. From the table, we can see that values using Euler is same, which is 200 grams, while midpoint and Hun's method resulting in same values from 0 till 60. Thus, we conclude that solutions obtained from RK4 method is more accurate since all value is almost the same with exact. Another real-life problem that uses same method is Newton's law of cooling. It predicts the cooling of warm object placed in cold environment. General population models can always be written in this form, where for this application the quantity of interest relates to number of given populations. Radioactive decay and carbon dating are another real-life problem that use separable method, and it can be shown as in the description. RL circuit has resistor and inductor connected in series. By Kirchhoff's voltage law, the result is in the following: dE